Good morning. We will have the analysis of the introduction of the concept of waveguides. To analyze the waveguides, we will have a look at the diagram of electromagnetic wave. This diagram clearly depicts the electric field representation and the magnetic field representation perpendicular to each other. The same analysis of electric and magnetic field perpendicular to each other defines the direction of propagation of the wave. So this can also be defined in terms of the wavelength. So this diagram very clearly depicts as the frequency of the wave is directly analyzed in terms of the wavelength. As we know, the relationship between the frequency and the wavelength of the wave are inversely proportional. The direction of propagation is exactly perpendicular to the electric and the magnetic fields. Now let us define what a waveguide is exactly. It's a metallic tube or a circular cross section, and as the name indicates, it is used for guiding the waves. Now they are either inside coated with silver or gold. For what purpose? To improve the conductivity of the walls and to ensure the inside surfaces are smooth to reduce the losses. Also, we can say that they guide the electromagnetic wave through the multiple reflections. This we will see in the diagrammatic analysis. Now, when the waves travel longitudinally, the plane waves are reflected from wall to wall, thereby propagating the transverse electric and the transverse magnetic modes through the waveguide section. Because of this multiple reflection, the guided wavelength is greater than that of the cutoff wavelength lambda c. Also, the physical velocity is less than the velocity of light we know, which is c, which is 3 into 10 power 8 meter per second. And they also exhibit the characteristic wave impedance. Now, as we know, the transverse electromagnetic mode can only exist in a transmission line and it did not exist in the waveguide section because it is requiring the axial conductors or axial current flow to support the transverse magnetic field. If one end of the waveguide is closed, then we can say that they can allow to propagate from the other end, thereby completing the analysis of standing waves existing. If the other end is also closed, then a hollow space will be formed, and that can support a signal which is bouncing back and forth, and this results in the resonance condition, thereby defining the concept of cavity resonator. Also, unlike the transmission line, the waveguides have frequencies which can be allowed only above the cutoff frequency. As we know, the definition of cutoff frequency is where the wave motion is being stopped, where it is being ceased out. So it is allowing only the frequencies greater than the cutoff frequency, and it can act as a high pass filter. Now in this diagram we will have the complete analysis of types of waveguides. There is a rectangular waveguide section, a circular waveguide, elliptical, single dish and double dish waveguide section. So as we define, the waveguides are conductor structure, single conductor structure. Transmission lines are double conductor structure. They are hollow in the center. They are made of copper walls. There is a thin lining of silver or gold inside, as we have already spoken. This is very clear part of analysis, and this is the angle of incidence and this is the angle of reflection. At this point it is getting reflected. So at high frequency, how this wave is being detected, at medium frequency how the wave is detected, at low frequency how the wave is detected, at cutoff frequency the wave motion stops or ceases out. And this is the very clear diagrammatic representation of the wave path in a waveguide section. Other than that, we have to speak about the various modes of propagation existing in transmission line and the waveguide sections. As I have spoken already, transverse electromagnetic mode can only exist in a transmission line, not in case of the waveguide section. The transverse electric mode and the transverse magnetic mode are the general propagation modes defined in terms of, for example, you can choose the definition of a transverse electric mode. Here the electric field is transverse to the direction of propagation. So, and the magnetic field will be normal to the direction of propagation. Vice versa condition exists for transverse magnetic mode, in which case the magnetic field is transverse to the direction of propagation, whereas the electric field is normal to the direction of propagation. These are the analysis of types of propagation modes. So these slides speaks about the introduction of the concept of the waveguide section. So in the next video, we will discuss about the subject in detail. Thank you.